Hi, this is the video for the Lockdown Knowledge Booster Higher 5. I think I should be given the volume of the sphere is 4/3 pi r cubed, so there it is. And now I'm assuming that in this tube the radius of the cylinder is the same as the radius of the spheres. So the volume of the spheres is, there are 3 lots of them, 3 lots of 4/3 pi times by 4 cubed. And of course if I'm multiplying by 3 and then dividing by 3, they cancel out, so I've got 4 cubed times 4, that's 64. No, it's not. I better get my calculator. 4 cubed is 64. 4 cubed times 4, 256 pi centimeters cubed. That's the volume of the spheres. Remember, the volume of the cylinder is pi r squared, that's the area of one end, times by the length. Sometimes it's called the height, sometimes it's called the length. Again, I think we assume that the length is the same as 3 diameters. So the length, 8, 16, 24, the length then will be 24. So the volume of the cylinder is pi times by the square of the radius times by the length, which is 24. 4 squared times 24, that's 384 pi. The percentage of the tube that is not filled, so not filled, is going to be 384 pi take away 256 pi. And it's the percentage of the cylinder. Clearly my pi's cancel out. 128 divided by 384 is 1/3. It wants the percentage, so I'm going to go for 33.33% to do 2dp. Of course, if you don't know that 1/3 is 33.3%, you could times that by 100, turns it into a decimal, but I'm pretty sure we know that 1/3 is 33.33%. So that's question number 1. Remember, for circle theorem questions, showing you're working out on the diagram is absolutely valid, and that's how I prefer to work. So before I even read the question, what can I see here? Well, I've got centre and circumference, so x is double that angle there, so that's going to be x over 2. Clearly 146 plus half x adds to 180, so for number 2 then I could say x over 2 is 180 minus 46. Oops. 180 minus 46 is 134. Sorry, 180 minus 146, send over your fool, is 34. So x must be 68 degrees. AOD is x. So I'm done. Number 3. I've got similar shapes again, and I'm given the area scale factor. So the area scale factor is big over little. So that's going to be 16. It wants the height. The height is a length, so I need the linear scale factor. Remember, the area scale factor is the square of the linear scale factor, so the linear scale factor must be the square root of 16, which is 4. The height of B then is 4 times the height of A, so 4 times 2 is 8 centimetres. Number 4, the area of this sector, well, that's 73/60ths of pi r squared, where r is 50 centimetres. So 70 over 360 times by pi times by 50 squared, 70 over 360. I'm not going to bother simplifying the fraction because I'm using my calculator. And the question wants it to 2 decimal places, so 1527.16. I worked in centimetres, so it's going to be centimetre squared because it's an area. Okay, question 5. Right angle triangle. So it's straightforward trigonometry. Trigonometry because there's an angle involved. Remember, side opposite my angle is my opposite side. Side opposite the right angle is my hypotenuse, which means the other side is adjacent. A and H are involved in this question, and A and H I can see as cos, so cos of an angle is the adjacent side divided by the hypotenuse. I don't want the cosine, I want the angle, so I use inverse cos to undo that cos operation. Now my calculator needs to be in degrees. It isn't because I was doing something else with it, but yours probably will be, but the little d means degrees. Inverse cos 11 over 15. Doesn't say how to round, so if it doesn't say 2dp and state 2dp. Okay, number 6. A UFO is lying above 2 people standing on the moon. So the text describes the diagram, which is often the way. Find the height of the UFO above the ground. Ooh, this is a tricky one, isn't it? Because these angles are not equal, I can't assume that these lengths are equal. So although it looks like it, I can't assume that. Now, what do I know? That's 67 degrees. I don't know that that really helps me. Okay, let's see what happens. That's 60 degrees. Right, so I'm gonna use the sine rule here. If I draw out the triangle without any of the pictures on it, I've got a 300 across there. That's 23 degrees. That's 127 degrees, and that's 30 degrees. I think what I'm going to do is I'm going to use the sine rule to find one of these two sides, and then look at one of the little triangles and use right angle trigonometry. So, in the big triangle, remember the sine rule, sine A over A, sorry, it's the other way around, isn't it? Sine A over A equals sine B over B, and a capital is an angle and a lowercase is side. So I've got this pair here. I'm going to find this side here, and because my unknown is a side, I'm going to flip these round. Right, here we go. So x over sine 23, because it's always the side and the opposite angle, is equal to 300 over sine 127. So x is 300 over sine 127 times by sine 23. Let's get an answer to that. Now I'm thinking ahead. I want to give an answer to 2dp, so I'm going to work to 3dp. So 300 over sine 127 multiplied by sine 23. I've already checked I'm in degrees from the last question. 146.775 to 3dp. In the little triangle on the left then, I've got 30, that's 60, that's a right angle. I don't know this and I don't care. I've got 146.775 and I want this height here. So I can pick either of these angles, doesn't really matter which. I'm going to use the 30, and in this then that's going to be my opposite side, that's going to be my hypotenuse, that's my adjacent which is not involved. So very similar to question 5 now. So TOA, opposite and hypotenuse. Right, here we go. Sine 30 equals x over 146.775. To get x on its own then I'll just multiply. So x is sine 30 times by 146.775. As it happens, the exact value is still on the calculator, so I can just times by sine 30 and round to 2dp, 39, we're talking meters to 2dp. So that's quite a big question. There's a lot of marks to be had with that sort of question. Okay, number 7. I know the mean and I know the number of pupils, which means I know the total. So if I've got a class of 18 times by 49, that's the total for the whole class. 18 times by 49 is 882. That's the whole class. The girls, 9 times by 37, got 333, which means the boys got whatever 882 minus 333 is, 549. There were 9 girls, which means there were 9 boys, so the boys' mean score is their total divided by how many there are of them, 61. Okay, number 8. Alright, here's my favourite question where you have to do a load of writing. Let's just check our numbers out. First of all, remember you compare the medians, which are equal, and you compare the interquartile ranges, so that's 0.35, that's 0.2, that's 0.33, and that's 0.24. So the interquartile range for the boys, 0.35 minus 0.2, that's 0.15. Sorry, I said boys, I meant group A. The interquartile range for group B is 0.33 minus 0.24, which is 0.9. Seconds. Right, so let's do some writing. So for number 8, compare the medians. The median for group A is equal to that for group B. You need to say which means that the, what are they, their reaction times. Average reaction time for both groups is the same. I know it seems like an obvious statement, but the medians being the same, you need to show that you understand that a median means the average. The interquartile range for group A, that's 0.15, is greater than that for group B, that's 0.9. Remember, if you quote these, they need to be correct. And a greater interquartile range, which means that, now in the past I've written that this data would be less consistent. That's true. I could also say the spread of the data for group A is greater. So I'd either say less consistent or more spread out. Both would get me the marks. Yeah, I could just have said less consistent. Okay, number 9. Right. Well, before I can do any of these, I need to know what these numbers are. And remember, in a histogram, the frequency is the area of each bar. So this has a width of 75, 0.2, that's 15. I better check these on my calculator, because why wouldn't you? Yeah, good, well done me. Right, this is going from 75 up to 125, so this is 50 times by 0.4, and that's 20. Good. Now this has a width of 25 and it goes up to 0.5. Now I appreciate that that's 12.5 sunflowers. We saw this in the last one. Let's not get hung up on the fact that it's not a whole number of sunflowers. There are reasons that that's okay, but they're beyond GCSE. 50 to 250, that's 100 times by, now I can barely see this from the copying, 0.1, 0.2, sorry, 0.11, 0.12, 0.125, 0.125, and that's 12.5. Okay, so in total, total number of sunflowers is 15, add 20, add 12.5, add 12.5, so that's that. 25 plus 15 is 40, plus 20 is 60. Right. The median, I need to go halfway along. I need to assume first of all that the sunflowers are equally spread out in each box. And I need to find the 30th. Now, if there's 15 there, the 30th, I need to go 15 into this box. So that's 15 out of 20. So, 15 out of 20, that's 3/4 of the way along this box. So 3/4 of 75 to 125. So 3/4 of, well, that's 50, a width of 50. So that's how far along I go, but I started at 75. Not a nice calculation to have to work out. So 112.5. Let me say that again. I worked out that the median is the 30th sunflower because I've got 60 in total. Well, I know that this box has 15 and this box has 20, so I need to work out where the 15th into this box would be. So because there's 20, 15 would be 3/4 of the way through. So I need to go 3/4 up here. And between 75 and 125, what I did was I went 3/4 of 50, because the width is 50, so that would be 37.5 from 75, so it takes me to 112.5. Nice. Not nice at all. Okay, the lower quartile, well, the lower quartile is the 15th flower. And that's easy because it's on a box, so the lower quartile is 75. So the lower quartile is 75. The upper quartile also isn't very nice because it's 15 down. Well, there's 12.5 there, so I need to go another 2.5 into this box, and it's going to be 2.5 out of 12.5. So it's going to be that fraction down from the top. The width, of course, is 25, and now I've got to take that off from 150. So let's work out how far down I go, and then 150 minus that is 145. Again, not a nice one because it doesn't fall exactly on a boundary. So then the interquartile range is the upper quartile, take away the lower quartile, 145 minus 75, 70 centimetres. Not nice at all. Histograms are difficult, particularly when the numbers don't fall on the boundaries of the boxes. Okay, number 10, this looks like a standard probability tree diagram. Let's have a read of it. If a student fails, they can retake. Okay, here we go. So the final exam is the first pass or fail. The probability of a student passing the final exam is 7/8. Okay, that means that the probability of a student, there you go, 7/8. That means that the probability of a student failing is 1/8. The probability of a student passing the retake, well, of course, if they pass, there's no retake. If they fail, there's a retake. So we can think of that. The probability of a student passing the retake is 2/3, which means the probability of failing is 1/3. There you go. Complete the tree diagram. Done. If a student passes the final exam or retake, they receive a certificate. Work out the probability that a student receives a certificate. So it's the probability of pass or fail pass. Well, the probability of pass is 7/8. Or, remembering probability means add. So fail pass, you go down the tree diagram and you, as you pass probability, you multiply. 1/8 times by 2/3, so that's 7/8 plus 2/24, 21/24 plus 2/24 is 23/24. Okay, let me know if you need anything else. I'll see you next time.